Hi, I'm Dr. Tahan, and I'm going to tell you a little bit more about aqueous deficient dry eye disease. Now, this disease has to do with the lacrimal gland. The lacrimal gland is a little organ located above the orbit of the eye and is responsible for tear production. Now, in a normal functioning lacrimal gland, the cornea of the eye and the surface of the eye is continuously moistened and lubricated. Like every other tissue in the body, the lacrimal gland contains adult stem cells. These stem cells are responsible for regenerating the lacrimal gland. In dry environments, the lacrimal gland starts to work overtime and starts increasing more and more tear production to make up for the evaporation of the surface of the eye. Now, over a long period of time, the lacrimal gland can wear out and degenerate, and the person is left with symptoms of feeling like grainy or sandy feelings in their eye that never go away. Now, short-term or temporary solutions can include eye drops or even drugs that would increase production of tears by the lacrimal gland. But in truth, these solutions don't provide a permanent solution. The lacrimal gland is a gland that sits above the orbit of the eye and is responsible for producing tears and providing the aqueous layer of the tear film. It functions to cleanse and protect the eye's surface as it lubricates and moistens it through tear secretions. This model here shows the 3D reconstruction of the ducts that go into the lacrimal gland acini. The acini is the cloud-like structure that is within the lobe of the lacrimal gland and is the functional unit responsible for producing tears and secreting oils into the ducts. Now, shown in the images are the green cells within the main interlobular ducts. These cells are the stem cells that regenerate the lacrimal gland. As you can see, most of the cells are located within these ducts, and in the lobes there's only just one green fluorescent stem cell. This model right here shows a 3D reconstruction of the mouse lacrimal gland. Now, in blue shown is the main duct that goes through the lacrimal gland. And now in green, the stem cells that are located within the lacrimal gland and located primarily in the inner lobular duct. Now, these stem cells are what are responsible for regenerating the lacrimal gland, and which leads us to our first treatment. Now that we know the location of the lacrimal gland stem cells, we can isolate them from a donor and grow them in culture. Using this cell culture, we can create an injection which would introduce new stem cells into the patient's degrading lacrimal gland. Ideally, this would regenerate the lacrimal gland and restore it to its normal function. One of the main issues we found in our first treatment was immune rejection of the adult stem cells since they came from a donor. Now, a way around this was to print a lacrimal gland that was 100% compatible with the patient. And since we had a 3D model, we decided to print it using a 3D printer. And this allowed us to transplant a brand new lacrimal gland using a highly specialized team of ENT surgeons and plastic surgeons into the patient with this disease. Now, a third option that we're still in the process of developing is a system similar to the encapture system that they use for diabetes treatment. Now, this system bypasses treating the lacrimal gland itself. In fact, we developed a system where we would take something that contains artificial tears and we'd place it behind the ear and have a tube that leads directly to the eye itself. And this would all be placed under the skin. Now, this tube would deposit or drop synthetic tears with either every blink of an eye or on a timer. And it would have to be replaced pretty easily once a day when it empties. Now, the advantage of this is that regardless of the functioning state of the current lacrimal gland, this system would continuously secrete a mixture of synthetic tears, and any excess tears would drain into the lacrimal sac at the corner of the eye and into the nostril and down your throat. So the patient would feel pretty much nothing, and besides carrying something the size of a hearing aid, would have their vision and comfort restored, and a really easy and quick solution that's minimally invasive and very efficient and cheap. We will continue to explore these different treatment options and try to find the most effective and efficient option for treating aqueous deficient dry eye disease. We hope to restore normal vision, and we wish many tears from our lab to your family.
It's been a long day without you, my friend, and I'll tell you all about it when I see you again. We've come a long way from where we began.